All right. Okay, we're back for part two. I know the lighting's not real great now, but I've had to turn on an extra light to make when I hold up a lot of the pictures and stuff to be able to see it. So looks like I'm telling scary stories here or something. But anyway, okay. So just a recap from part one. I've got, speaking of pictures, if I can do this right, here's just a nicely drawn area of the air masses that we have here affecting North America. All right, so we've got those warm, wet ones, the maritime tropicals down in the south. We've got the maritime polars there in the northeast and the northwest. We've got the continental polar from Canada in Canada, and then in the northern Canada, we've got that continental Arctic. And again, the ones that we worry about here in the Mid-South region and through that whole wide area, this is really good because it shows you the mountain ranges to the west and also our mountain ranges in the eastern part of the country that are there. And you see that wide open space in between. That's where the cold air comes in and meets up with the warm, wet air from the south, and the battle ensues. All right, I know we got some glare here, but I'm doing the best I can right now. So anyway, so you can see that, and so that's just a little better picture of those things. So what I'm going to show you now is what makes these air masses move. You know, why do they, they're nice and lazy being up there in Canada. What makes that continental polar move down south? All right, so that's what we're going to talk about next. What I'm going to show you, if you guys remember, is we've got the two layers of wind on our planet. All right, remember we've got the surface winds, which are down low, but then we've got the upper air winds, those geostrophic winds that are occurring at the higher level. We're still in the troposphere, but they're still higher up, and it's these upper air winds that we're dealing with. And for us here in North America, and just about everybody, those are the prevailing westerlies, the upper westerlies that are going to be blowing. Let me get in, where are we? There we are, all right. That are going to be blowing from, thank you, there's a message, all right. I didn't know that was going to be showing up on here. It'll go away shortly. Anyway, the winds come and move across, okay, from west to east. This next diagram I'm going to show you, though, is going to be taken from this perspective. We're looking at the North Pole. There we go. Yeah, all right, the North Pole. Okay, so it's this perspective right here. And we're actually going to be looking at the jet stream, that polar jet stream, which I said, and for most things, to make it, think about the polar jet stream as far as North America, it tends to normally occur right around the Canadian-US boundary is where it kind of normally flows, all right? It flows all the way around the planet, right around that approximate latitude, all right? And that's where we have, of course, cold air on the top from the polar areas with a slightly warmer area in the mid-latitudes. And that boundary is known as the polar front. Now we know that the term front is the boundary on the ground between two different air masses. Well, everything's hunky-dory when that polar front and, the jet stream itself is flowing, pretty much a nice little smooth path, all right, which is what it looks like. Oh, wrong one, right here. All right, so this is looking down. North Pole is in the center. All right, you can see right here, right where my finger is now, is where North America is, and that's where it normally looks, circle-ish. But a lot of times it starts to get wonky, just kind of like a top wobbling and stuff. And you can see in this next picture down here, where is it? Over here. All right, this picture on this side, that the boundary starts getting little lobes and stuff like that in it. And they can even extend, if I do it right, here we go, and get extremely wonkified. Make sure I go the right direction. Nope, this way. Here we go. There you go. All right. And you see that you get things start to pinch off. All right. This little piece, I can't see what I'm doing here. All right. So right here is going to be set up a low pressure center. So let me show you this in another type of diagram, a little more kind of up close type deal just for North America. But the key thing to this is that you have the polar front, that's the blue air where it meets up with the red. Okay, so that's colder air meeting up with slightly warmer air. And, moving around there, that's where the jet stream usually is. That's located closely around that border. And then it starts to get wobbly and pinch off. So let me show you those pics to help explain what's going on. All right, so here we go. There we go. Okay, so I'm going to stand up so I can try and point these things out to you. I can figure out how to hold it and point at the same time. All right, so up here is the normal, situation. All right, cold air on top, warm air on the bottom. The boundary between the two is not moving, so we have a stationary front. You recognize the symbols there. But again, we get kinks in it. For some reason, the cold air decides to start swinging down, and the warm air starts swinging up. All right, so that stationary front has now turned into a cold front with the cold air pushing down this way, and a warm front with the warm air swinging up. Right at the kink, right at the hinge of these two is where a low pressure system will develop. Now this is a cyclone. It's not a big giant seasonal cyclone like we had saw when we talked about first time, like when we talked about Canadian highs and Aleutian lows and Icelandic lows and things like this. This is a secondary in size. In fact, it's called secondary cyclones. It's low pressure, so it's a cyclone. These are still quite large, but they are maybe last about 2 weeks or something like this. It's an entire life cycle that goes on. But this is what's going to be forming the mid-latitude cyclone. These mid-latitude cyclones are what get birthed up here at the polar front, and then move on down across and bring the changing weather with it. So as the cold air starts to move on down, now remember the cold air is denser, so it moves a little faster. You notice how the hinge it's more bent here on the hinge. So the cold air is moving in. All right, so we've got warm air trapped between a closing mouth of cold air. All right, down here, it has progressed a little bit further. All right, you're seeing how the area of warmer air is getting smaller as this goes in. Basically, the cold front zips up with the warm front. Here we have an occluded front, but as this is just zipping up, all right, again, our warm air mass down here is still smaller. And finally, the whole thing, the cold front's going to eventually run up the back end of the warm front here, and it's going to zip up, and the whole thing's just going to dissipate, and we'll be, right back where we started from. All right, so this is the life cycle of a mid-latitude cyclone. It goes through these stages from birth, and then the cold front comes on down, and then eventually zips up, meets up with the back end, back to here. Again, approximately 2 weeks or so. Now, one thing to keep in mind is that this is not static. Okay, where it births, remember the winds are blowing. Those prevailing westerlies are blowing toward the east. And as a result, over the course of this process, the entire low is moving across, I type this right? There we go. Across the country. No, I'm going the wrong way. I want to go down. There we go. These red lines are storm tracks. It's the way that once those secondary lows are formed, those mid-latitude cyclones are formed, they tend to move across the country. So like if it's birthed right up here, as it's going through those stages, it's still moving across the country. They tend to go down, they move in toward the east, and then they usually hang up, okay, and tilt up toward the northeast this way. All right. If I get in a little bit closer, you should be able to see the path that follows through Tennessee and Memphis. So it's this one right here. So this is, again, this is why we look to the west for most of our weather, because you can see it hits Arkansas. Actually, it hits Oklahoma and Kansas before it hits us. Then it goes, or excuse me, Texas and Oklahoma. Then it cuts through Little Rock there in Arkansas before it hits us. And then it goes up kind of to the north and into Kentucky. Folks in Middle Tennessee and East Tennessee are on a different storm track. So usually Nashville doesn't look to Memphis to see what's headed their way. They tend to look down to like Jackson, Mississippi. As you can see, that lower one follows up there, the same way with the folks in Chattanooga and things like this. But all of them follow the same basic trajectory, is heading east and then swing up just a little bit still to the northeast. So as these stages over here are occurring, it's all on the move. So the initial lows form, say maybe right up here, and then as it's going by and zipping up, it's moving down through. But it's following those low pressure centers that gives us our changing weather. And I just went outside today and it's like freaking cold out there. Of course, we didn't have any sunshine to warm things up. All right. So what you're going to do, also, I'm going to show you a couple of diagrams to emphasize. These are the better drawn diagrams of what's going on with those cold air masses versus the warm air mass that I drew out for you. But these are, again, other nice ones. I'll get at that. I know you don't care about those messages. I don't know how to block that. So, well, okay. Back up. I need to go up. Here we go. I'm getting my directions down. So anyway, so here's where you've got the cold front coming in, all right, with that big steep slope of discontinuity. Cold air is coming in, warm air is going up, and you're seeing our different cloud types, which are forming on this, so you can look at that and read that. All right, and let me show you the back side of that. No, and down. That's what, there we go. I'll get it right one of these days. Down, down. All right. And there we go. All right. So there's the backside where you got the warm air moving into the cold air. And you can see the slope of discontinuity is much more gentle. You see we're getting stratusy type clouds instead of the vertical cumulonimbus type clouds. You've got a much wider area of rain than you would have before. And you can also see how naturally cirrus clouds form, all right, as opposed to the ones that come from the contrails. All right, I'm going to show you another set of drawings of these. So, hopefully one of these are going to click with you pretty easily. The more you look at these, the more you kind of dissect them, hopefully the more they'll make sense to you. All right. So, now I'm going to go down and try to tilt this, and then I need to go this way. Try to work off the glare. So here's one, down. There we go. All right. So you've even got the symbol for the cold front there. It's just another version of the cold air mass invading in the warm. And then if I show you this, here's another version of the warm air, all right? So with a warm front moving in to the cold air. All right, so if you ever want to take a screenshot of this or pause it on this or something like that, feel free to do that. That's the wonder of this. You can look at that as long as you want to. Again, you don't have to worry about any of the elevations. Just know, lower, higher type of situation that goes on. The second drawing, let me back up just a little bit. This is the tail end of this, okay? So if I could pick this up and glue it onto here, that would give you the full idea. All right. So what we're going to do is look at a weather map. And you're going to actually do this. This is part of the lab that you can do. Where you are in your lab book, we're in exercise I, and you want to look at I-5. All right? So it should be somewhere around, my version, I can't read this, page 153. All right? I'm going to see if I can get out. No. All right. But anyway, this is what I'm going to be doing. I'm going to show you guys all about it. All right. But we're going to be drawing one of these pictures. All right. So again, here it is, but you should have it in your workbook to do. And what you've got is this right here. All right. So this is, we're starting out. It's similar. We've already seen a picture just like this. These are isobars. This is showing us the pressure readings across middle part of the United States right here. All right. And you can tell that it's a low pressure center. So this is one of those mid-latitude cyclones that has been formed. And we're going to draw all the parts that are on this. We're going to show you where the cold front is going to be, where the warm front is going to be, where the rain's going to be, what the temps are going to be like, and things like this. All right, so if you need to look at that, that's what you're starting with. Now, even though I'm going to show you the actual answers that are on here, I suggest that on your own, you also attempt to draw this, because it's going to help you remember by drawing it, helping you with the terms and hopefully understanding and getting very familiar with this. This is the type of thing you will see on your regular weather map, whether you go to weather.gov or you actually watch TV with the weather or something like this. So let me see if I can get this in a place where I can hold it steady and where you guys can see. So I'll try to hold it as still as I can. So again, if you want to take a screenshot or something of it. But this is what it looks like completed. And I'm going to talk about these different portions, and I'm going to try and hold it so I can point at things as well. Maybe one of these days, by the next ones, I'll figure out a way I can actually set stuff on the ground so I don't have to try and hold it all up here and have it wobble. All right. But, all right. Of course, remember the isobars. All right. Those give us a clue as to where we need to draw things. So, of course, we already know where the center of the low is, which is right up here. All right, and so this line with these looks like little pinch marks. All right, so you draw a line connecting those all the way down. That's going to be your cold front, and the air is moving this direction. All right, so you got to make sure to put the triangles facing down the way they are in the drawing. All right, because that shows you that the cold air, which is this entire section up here, is the cooler cold air. And it's moving down like this. All right. Now, on this side over here, you may have noticed that it's not near as distinct as the pinching in the isobar lines that we saw over here, but there's a little bit, like the beginning of a pinch. That is where the warm front is going to go. So the warm air sector is down here. No, that's not working. Here. So down here is the warm air sector. All right. And the warm air is pushing up this direction. All right, pushing up here. All right, so cold air. I don't know what this is, but it's stop. Yeah, I'm about to lose all my pins roll off. I'm playing over here. Okay, so here's all our cold air, and it's moving down this way. Whereas the warm air is moving up this way. All right, so first thing you'll do is draw those front lines. So cold front and warm front. All right. Label this the cold air sector. If you want to like shade it or highlight it a different color or something, whatever helps you, that's fine. Warm air is down here. All right, so from here, so this whole section, that's the warm air. All right, so it's easy to see Memphis is still in the warm air sector for right now. Okay, we're right here in the far southwest corner of Tennessee. If you want to use us as an example. Okay. Now, some of the things I also asked to draw on here. First, they were wanting, we were wanting to draw the winds, which we did before already. All right, so we know the winds, this is low, so the air is coming in, converging on it. And so this section, we've got the winds coming in this direction from the north. All right. In the warm section, the winds are going to be coming up kind of from the southwest or south, a little more southeast as you get over here. And up in the top area, again, they're coming around this way. Okay. One thing that is very specific is at the cold front line, there is what they call a wind shift line. All right. While you're still in the warm section, before the cold front has reached you, the winds are coming out of the south. Might be southwest, southeast, but you got the south general idea. As soon as this front swings on by and passes it, the winds are going to shift. The winds are going to be coming out of the north. This is something that's very easy to see. I see it at my workplace all the time because we got flags on a flagpole, which, if you guys will remember, act as a wind vane. And so, some days when it's nice and warm, the winds are coming straight out of the south, and the winds, flap the flags so that they are pointing to the north. All right. But then when the cold shows up, you look up and the winds are blowing from the north instead. It's a very, very obvious wind shift type of thing that goes on. Okay, it's one of the things we look for. Now, rain. All right, they were asking you to label the rain. So we got diagonal, or we've got vertical lines showing you where the rain is found with the cold front. Well, the cold front, the rain is just a very narrow band right on the front itself. You may also occasionally find some rain bands just in front. That's what I have labeled a squall line right here. It's that little red dotted line that goes up. We will talk about squall lines in more detail when we talk about severe weather. All right, but it's just it's a chorus line of thunderstorms, but it's a very distinct line. And then there'll be a gap, and then you'll have maybe another squall line right on top of the front itself. The key here for your information right now is that with a cold front, it's a very narrow band of rain. We know it's a lot of times those cumulonimbus clouds, those vertically enhanced clouds, all right, because the warm air is going up that steep slope of discontinuity, all right. With the warm front, remember, we've got a much wider band of rain to deal with, and so they asked you to draw in horizontal lines for that. So you see it covers a much wider area that is getting some rain, all right, in precip. And then, of course, we also know that just low pressure, even by itself, you're going to get air rising up, you're going to get adiabatic cooling, you're going to get clouds and probably rain. And so these diagonal lines are just rain associated strictly because of the low pressure. All right, they aren't tied in so much with the cold front or the warm front. If you happen to be like here, the boot heel of Missouri, that is right at the center of the low, you're getting double whammies. Your weather can be crazy, and it's probably going to stay crazy for quite some time because you might be getting some storms from this cold front. You might, get lingering rain from this and lingering rain from that and all kinds of stuff that goes on. They did ask us to, put some examples of temperatures. In the warm air section, you notice that I've got, I just happen to choose 70, degree stuff. So, just kind of randomly scattered some 70-degree weather around, knowing that it generally gets warmer down in the south. So I got it 80 degrees in Florida. In the cold sector, of course, it's got to be colder. This is the push of the colder air from up here. Over here, it's still cold, but it's more cool. So I've got like some 60 degrees over here. But then notice it's like down to the 50s. over here. So we're making this a pretty significant situation as it goes through, okay? So once that cold front goes through Memphis, even though we've got like 74-degree weather for us right now, as soon as that front passes, it's going to drop down to like in the mid-50s. And this could literally be, it could take several hours overnight, but I've experienced it where it literally happened in 15 minutes, where we've had 10 and 15-minute temperature jumps in that short of, or 10-degree temperature jumps in 10 minutes. It doesn't happen very often, but it does happen. All right, so that's going on. So they also ask us to show where we might get some severe weather. Again, we'll talk about tornadoes and things like this more likely, but they're very much more likely to be associated with the squall lines that you find in front of the cold front. All right. Now, these guys over here, okay, so for the weather for Georgia and for Florida, Alabama, even Mississippi, this hadn't reached them yet. And so at this point in time, this snapshot of this picture, they just might get some good old convective afternoon thunder showers. They're just, has nothing to do with this mid-latitude cyclone coming through. It's just, they've got sunny skies or whatever by late afternoon, with all the humidity and the convective air riding up, they get these convective showers. All right. So the thunderstorms and severe weather, they're associated with the squall line. But these are just little afternoon pop-up ones that go on. All right. Now your lab question for this lab, and again, I don't remember the numbers right off the bat. It's on your pause. It is just a set of 5 questions based off of this information. So you'll need to, be able to look at this and understand it and read it and then answer those 5 basic questions. All right. So hopefully that will do you up. Now, one last thing. This right here, this heavy line, this is showing the direction of movement of this entire cyclone. All right. So we know that it has moved across following the track kind of this way, but then it's probably going to veer up this way. Looking back at the storm track pictures that we did. So originally this low probably started way over here, and the center of it moved on down here, and then it's going to be moving up this way. All right. And so you can make predictions, and this is what we're going to be doing in next week's lecture before test 2, is working even more on this information right here, knowing what we know, what we've learned on this, but being able to do our own weather predictions. So you can get to the point where you can go to the weather map. You can see where the fronts are. I mean, they'll be drawn out for you. That's okay. And where the different pressure systems are and things like this. And you can say, okay, this is what the weather is more than likely like right now. And then I can make the prediction of what it's going to be like tomorrow. All right. So knowing that this is going to be shifting this way, obviously Memphis, the cold front's going to come through. So the next 24 hours, the cold front will have passed by us. We'll be in the cold air, so we know it's going to be cold. Skies are probably going to be clearing, although we might be stuck in just some lingering rain from the low pressure, so it might be cold. It might be like it is out today. This is Sunday evening, like this. All right, as this moves on and then goes up here and then dissipates and falls apart. And this time of year, especially in the spring, where we've got the biggest temperature difference between the quickly warming southern areas and the still cold northern areas, we can get multiple mid-latitude cyclones that form. One forms and then 2 days later another one forms, and they're following right in behind each other, and it can get kind of complicated. So Mr. Smith, Ken Smith, I knew my Kens. When your question is, well, it's not following these steps, it's because real life is a little more complicated. Remember, I'm trying to keep these as simple as possible. All right, but we'll be looking at that in more detail next week. So anyway, that is, I think, all that I have for this. Be looking for, the emails. Email me back if you've got any questions about anything. Hopefully the quizzes and the assignments that I've got on there are working right. Shoot me an email if they're not, and I'll do what figure out what I have to do to fix it. I again, the test too, just read up on the email, and if you've got any questions about that, I will be, again, it'll be available. I'll send you out the email with the test copy and everything like this next Wednesday, all right? Maybe late Tuesday night or, by Wednesday morning and stuff like that, so you can start working on that. And again, use all these notes, use these lectures, use other textbooks, Google stuff, do whatever you can to fill it. Don't forget that I've got study guides that are always been on the pause that are listing all these concepts, all the vocabulary words that we're using. So they're listed on there. So, you can look over ones you aren't familiar with, look them up. All right. Use a textbook, use Google to get some better ideas and things like this. So it's okay. We'll get through this. It's fine. And we're going to be fine. It's going to be okay. Ask everybody, stay healthy. Do what you can. This will help you, keep you stay inside. Poke your head outside, go down on your, in your yard or something like that. That's going to be good for you. But look at the sky, watch the weather, see what's going on, see if you can start learning to predict it. Things happen the way you're expecting them to happen and things like this. So I will see you later. Bye.